Okay, so this recording is for part 2 in lesson 1 on Trig 2. What you're going to do is you're going to need your calculators and make sure that according to, we're going to graph this question, we need to be in radian mode. So on your calculators, just make sure that it says radian, and then we'll be able to do this question. Okay, what we are going to do, I'm going to show you 2 different methods on how we could solve this question, which we just did on the previous page, how we could solve this on our calculators. So what I want to do is one of the methods that we could do, so I'm going to teach you 2 different methods. I'm going to bring this -1/2 over to the left-hand side, and that would give me the sine of x plus 1/2 is equal to 0. This method here, if we punch this into our calculator in y1, because I have a 0 on the other side of the equation, this is what we call the 0 method or the x-intercept method. So when we solve this on our calculator, it's called the 0 or the x-intercept method, because we're going to be looking at the x-intercepts to get our solutions. So a few things. We want our calculator, according to this window, we want to go from 0 to 2 pi. And then just to double check the scale, so let's write the scale over here. The scale would be, count how many hatch marks you need to get to pi radians over there. So 1, 2, 3, 4, 5, 6. So the scale, 1 hatch mark or each box represents pi over 6. And they actually give us the window right here. So we're going to go from 0 to 2 pi to pi over 6. That's going to be our x window. And our y window, they want us to go from -2 to +2, and each hatch mark is worth 0.5. So let's take out our calculators. Let's punch this into y1, making sure that we're in radian mode and our window is right there. So let's punch this guy in. So y is equal to, if you have anything there, clear it out. And I'm going to type in sine of x plus 1/2. So sine of x, make sure you close that bracket. And then put plus, you can either put plus 0.5, or I'm going to put my 1/2 in a bracket. I'm going to go right to window, and I'm going to enter the window that they told me, which was 0 to 2 pi. And then they want my scale to be pi over 6 radians. They want my y window to be -2 to +2. And they want a scale of 0.5. So this is what you should see if you are in radian mode. Now we know the answers, right? Because we solved this in the review on the previous page in A, question A. And if I just quickly look back, our answers were 7 pi over 6 and 11 pi over 6. So these two are, our solutions are going to be the x-intercepts or the zeros of my graph. We could do this in one of 2 ways. We could count if we really want to, because I know that each scale is worth pi over 6, or each box. So 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7 pi over 6, 8, 9, 10, 11 pi over 6, right? But I want to show you how you'd actually get this on your calculator. So on your calculator, what you would do is hit second function, calculate. And we are doing the 0 method. So we're looking for an x-intercept, which is a 0. What you want to do is go to the first x-intercept that you're finding, and we're going to go left of the x-intercept, hit enter, go right of the x-intercept, hit enter, and then hit enter again when it says guess. So we get this answer here. Let's convert this to pi radians. So you need to get out of your graphing window, so quit that. And in order to get that x value, you just, right next to your alpha button is the x button. So x, enter. That was our solution. That is our answer, right? Our answer is 3.665 radians. How we get that though in exact pi radians is divide that number by pi and then math one fraction it. So one of my answers, that first x-intercept, is 7 pi over 6 radians. So solution is 7 pi over 6. That's one of my solutions. Just to double check, remember I said like this was the answer here because that was the 0. I'm just going to type in 7 pi divided by 6 and see if I get this exact answer. So 7 pi, divide that number by 6, and you get that exact answer. Let's find the second 0. So go back to your graph, see if you could find this one. So second function, calculate. Going back to, when did we teach you zeros? 20-1. You're doing number 2. I want to find this 0. So first I hit the left button, hit enter. Then I hit the right button, go above the 0, hit enter. And then when it says guess, you just hit enter again. It will jump to the 0. The answer is this, but the question said in exact pi radians. So I need to get that x value. I need to divide that number by pi. And then I need to math one fraction it. And my second answer is 11 pi divided by 6. So 7 pi over 6 and 11 pi divided by 6. So just to go back to the review, if I go back to this first page, this question here, now you have 3 different ways you could solve this. Unit circle is your first method. Algebra, which we did here, algebraically, is your second method. Bring this over to your, bring the solution over to the left and just punch that into your calculator. That's the third method. And I'm going to show you even one more additional method to that. Okay, so we've got our 2 solutions graphically. And now what I want to do is we're going to talk about the general solution. Okay, so the general solution, just draw yourself a Cartesian plane. So we had 2 solutions for this question, sine of x is equal to -1/2. We had a solution of 7 pi over 6, and we had a solution of 11 pi over 6. So what you're going to have to be able to do in this lesson is once you get your answers, they're going to then say what's the general solution. So how you get the general solution is I'm just going to show you back on our Cartesian plane. 7 pi over 6 was right here. So that's 7 pi over 6. And then we had a solution in this quadrant at 11 pi over 6. I actually did talk about a general solution briefly in Trig 1, but what the general solution is this 7 pi over 6, if I keep adding or subtracting, the general solution is just what are all of the possible solutions. So if I take the 7 pi over 6, and let's say I add 2 pi, and then I add 2 pi again, or I keep subtracting 2 pi, how would you write that as a general solution? What you would do is you would take your x, you would take that 7 pi over 6, and you would just keep adding or subtracting 2 pi radians. And to show that you're going to add or subtract, you just tack on an n at the end. So that means you could go in the positive direction once, twice, or you could go in the negative direction once, twice. The second general solution, because now we have to do the general solution for this answer. So you're going to hit comma. So the second solution was 11 pi over 6 plus 2 pi n. Once I have both of those general solutions written, I could then add at the end of this, n belongs to the element of the integers, just to say that I could be adding or subtracting 1, 2, 3, however many times I want. So that's how we would get our general solutions. Okay, let me show you one last way you could enter this onto your calculator to get your answer. So one last method we could do is the equation that they gave us was the sine of x is equal to -1/2. The last method that you could do, it's called the intersect method. And the intersect method is you simply do not change anything in what you were given, and you just type this into y1, and you type this into y2, okay? What we're gonna do for our intersect method, let's not change our window, like even though they're showing this, they've changed the window here. They're going to want the answer from 0 to 2 pi. So let's just type this into y1, this into y2, and let's see what we would get on our calculator. So go to y is equal to, let's clear this. Let's just type in the sine of x. And let's type in -1/2 in y2. We're not going to change our window. And I'm just going to go to graph. If you do the intersect method, your solution is where the two systems intersect each other. So let's just verify doing one of the solutions because we know the answer, right? This should be 7 pi over 6 and this should be 11 pi over 6. So let's just verify that. Let's just do one of them. Let's do the closest one. So second function, calculate. If you do this method, you're looking for number 5, which is an intersect. What you do is you go close to the intersect. You don't even have to touch it if you want, but go close to it. When you're doing intersect, what you have to do is you have to hit enter 3 times, and I suggest doing it relatively slowly. So just enter, enter, enter. That will give you the intersect. If they asked it to the nearest, let's say 10th, your answer would be 3.7. If they answer in exact pi, if they want the answer in exact pi radians, that's where you're going to do, okay, what was that x value? Divide that x value by pi, and then math 1 fraction it. And you get 7 pi over 6. The other intersect you could check later, you would get 11 pi over 6. So that is the intersect method. Okay, so now that we did that, let's go down here and we're going to actually start the class examples. So that all, for the most part, should be a review. This is the notes on what we just did. So it's just showing that there was 2 intersects, there's 2 methods, the intersect method or the zero method. Once you get your solution, this is showing you how you would get the general solution. What you do to get the general solution is you add or subtract multiples of the period. And remember, for sine or for cosine, the period is 2 pi. That's why for sine or for cosine, we add or subtract 2 pi n is what we would do. If it was a tan graph, and I don't think any of these questions are tan, the period for tan, remember, tan repeats itself every pi radians or every 180 radians. So that would be the period for a tan graph. Okay, let's do class example 1 now. And it says solve this equation using 2 different graphical approaches. We're just going to do one approach. So let's write the question. So the question is the cos of x is equal to 0. All I'm doing, you guys, is I'm adding 0.75 to both sides. So cos of x is equal to 0.75. So we're going to get the answer in 2 different ways. We're going to just do it graphically doing one method, and then we'll do actually algebraically, because I think most of you will do your work algebraically. So to solve this algebraically, let's find the reference angle for this. So we need to be in radian mode. So let's just make sure our calculators are in radian mode. They are. Let's clear what we have. Okay, let's find the reference angle. So the inverse cos of the absolute value of this number, that is going to give us our reference angle. So second cos 0.75 gives us this number here. It says to the nearest hundredth, which means we can't convert this to pi radians, exact values. So to the nearest hundredth, it would be 0.73. That would be our reference angle. That's theta r. Draw yourself a little Cartesian plane. Write your cast rule. And check off the two quadrants where cos is positive, right? This is a positive number. So cos is positive in quadrant 1 and in quadrant 4. Take that reference angle, put it in quadrant 1, 0.73. What would that angle in standard position be? It would be whatever the reference angle is if we're in quadrant 1. So one of my solutions is 0.73. Oops, that should be a 3. That's one of my solutions. My other solution is in, where are we? In quadrant 4. So in quadrant 4, put a reference angle of 0.73 in. They want the angle in standard position. So what would this rotational angle be? So we're not quite going to 2 pi, but our second answer is going to be 2 pi minus 0.73. So to get our second answer, 2 pi's minus the reference angle is 5.56. So that's my second answer. Those are my two solutions. And then they want right now, after we get that, I just got to double check. It said that one of the answers was 0.72. So let me double check that. Oh, sorry, I rounded. This should be, the reference angle was 0.72. So just let me fix that. Okay, so those are our two solutions. Now we need to write each one of these as a general solution. So writing this as a general solution, you would say x is equal to, I'm going to take that answer, 0.72, and to that answer, I'm going to add 2 pi n. That will give me any solution in the domain of XER, comma. I take my second solution, 5.56, and to that solution, I'm going to add 2 pi n. And then at the end, I just tell my reader that n belongs to the set of integers. So I could keep adding or subtracting positive or negative integers. So those are my two solutions. To quickly double check this on a calculator, like how could we graph this? Because it did actually say do the answer graphically. We did it algebraically. To do this answer graphically, it doesn't matter what method you want to use, but let's just do the zero method. So the way they gave me the question would be the zero method, because I would just type that simply into y1. I've got a 0 on the other side, so that would be the 0 method. So let's just quickly check our answer using the 0 method. So cos of x, and remember our window shouldn't change. So our window should be set from 0 to 2 pi, and each hatch mark is pi over 6, which I believe we have. So let's go to our calculators. So take your calculators out. Let's go to y is equal to, punch in that cos of x, close that bracket, and then minus 0.75. Your window should be from 0 to 2 pi and pi over 6 radians. So we don't need to change our window. We could graph this. Our graph has two different solutions. Let's just get one of the zeros to verify. So second function, calculate number 2. You guys could double check either 0. I'm going to go to the right 0. And I'm just going to double check this one. So if I want to know what that answer is, I go left of the 0, hit enter, go right of the 0, which is above the x-axis, hit enter, and then guess means enter. X is equal to 5.56. Let's see if that's what we had. Yes, 5.56. So several different methods that you could use, right? The other method that we could do is I could type this into y1, this into y2, and I could do the intersect method. So various methods. Okay, let's flip the page and let's do class example 2. So hopefully this one we're not going to graph, so we'll get through class example 2 quickly. Okay, so what I want you to do, what it says is use an algebraic. So chances are on your test, I'm going to say use an algebraic procedure to find the general solution of this equation here. So what I need everybody to do is I need you to isolate for me cos of x. So if everybody could isolate that, and then I'll pick somebody to give me what cos of x is isolated. So get rid of that root 3 and then get rid of that 2. Lander, what do you get the cos of x is equal to?
Oh, sorry, I'm not done yet.
Not done? Okay, I'll give you a minute to finish that off. So again, you're just getting this guy Lander by itself.
Is it square root of 3
Yep,
over 2?
that's exactly what it is. Root 3 over 2. Yep. Cos of x is root 3 over 2. It wants the answer in radian measures. So I'm going to show you first how to find this just on your unit circle. So we know that the cos is our x coordinates. So actually, let's do our cast rule first. So once we get that, we should always be doing cast. So according to cast, check off the 2 quadrants where cos is positive. So everything's positive in quadrant 1 and in quadrant 4. So now what I'm going to do, just to find my solutions using the unit circle, I am going to look for my x coordinate. Where is x root 3 over 2? Right there in quadrant 1. And if I go to quadrant 4, right here. So my 2 solutions are going to be pi over 6 and 11 pi over 6. So I'm just going to write it down here. So x is going to be equal to pi over 6 is one of my solutions, and 11 pi over 6. So those are my 2 solutions. But it asked me to do this algebraically. So even though I know what the answer is, now I got to actually do the work for this. So if we're doing this algebraically, we must figure out what the reference angle is. So we're going to do the inverse cos of the absolute value, which is just going to be the same answer, so root 3 over 2. Because we're on the unit circle, we could get our reference angle in exact pi radians. So let's figure out what that would be. So type in on your calculators, make sure you're in radian mode. Second function cos of the square root of 3. Scroll out. So make sure you scroll out, divide that number by 2, and hit enter. We need to, that is my reference angle right there, but I know I could get that number in exact pi radians. So divide that number by pi and math one fraction it. And I get 1/6 and tack on a pi. So the reference angle is pi/6. So write down pi/6 and make sure you always write down when you do the inverse cos, that always gives you your reference angle. You then take your reference angle of pi/6 and you put it into each of the 2 quadrants where the solution is. So one of my solutions is here, and because we're in quadrant 1, I don't need to do any work because the reference angle is equal to the rotational angle. So in quadrant 1, my answer is just pi/6. We then need to have an answer in quadrant 4. So you need to write a reference angle of pi/6 in quadrant 4. They want the rotational angle, which is this guy. We're not quite going to 2 pi. Remember, in quadrant 4, you're always going to use 2 pi. So the algebra for quadrant 4 is 2 pi minus the reference angle. We need to get common denominators. So multiply this by 6, multiply this by 6. 12 pi minus 1 pi is 11 pi/6. So that's how I would algebraically show my work. Now they want the general solution. So once I have my solution, I could then write a general solution. So this was one of my solutions, and to that solution, I could just keep adding or subtracting 2 pi radians. So I'm going to take that first solution, which is pi/6, and to that, I'm going to add 2 pi n's. I'm going to take my second solution, which was 11 pi/6. To turn it into a general, I simply add 2 pi n's. And then at the very end, I just say n belongs to the element of the integers. And that's how I would write my answer in a general solution. Okay, now we're going to do class example number 3. So for this one, sine of x is equal to 0, cos of x is equal to 0. What I want you guys to quickly do for this is I want you to draw, whenever we have 0 or 1s listed, your answer is going to be on the axes. So I want you to draw your 4 points and put in those coordinates. So this coordinate here, x is 1, y is 0. Here, x is 0, y is 1. Here, x is -1, y is 0. Here, x is 0, y is -1. Sine of x is equal to 0. Sine is our y values. That's a sine value. Sorry, what am I doing? We want the answer where sine is 0. So sine is 0 here, and sine is 0 here. What are those solutions? So the solutions to this would be, I know that it's 0. Over here, this is a solution. So like this was one of my solutions. And this guy. So 0 radians, I go over here, and this is pi. So that's a solution. And then I actually have one more solution. And back here, if I go once around the circle, this is 0, but it is also 2 pi, right? Because that's always 0, and then once around is 2 pi. So those are my solutions for where sine of x is equal to 0. If you typed in, like on your calculator, the sine of pi and hit enter, or the sine of 2 pi, hit enter, or the sine of 0, hit enter, the number 0 would spit out. Okay, how do we write the general solution for this? So this one's a little bit more complicated. And your answer, you guys, so our solution was like, so we had one solution here, and we had one solution over here, right? Because pi was a solution. This makes a straight line. If you have two different answers and they're on a straight line, I tell students this looks like a propeller, right? Like this straight line, I could spin this line. So how you would write your general solution if your answer is on a straight line, what you would do is my general solution is, we're not going to take 0. Okay, so just ignore the 0. You're going to look at pi. So if this is pi, how do I get back to here? What would I have to add to this? I would be adding, if this is pi, to get to 2 pi, I'd be adding pi radians. And then like to get over back to here, because this is another solution, I'd be adding pi again. So if ever you have a solution that is two solutions and it makes a straight line, what you do is you're going to take the pi, and to this, what you're going to add, or sorry, you're not going to add anything. You're just going to say the solution is pi n. Because I could take this pi and I could just keep adding another pi or another pi to it. And then we would say to this, n belongs to the set of integers. That would be my general solution. And I'm going to, it'll start making more sense once you see cos and how we would do that. So your general solution is going to be different when your answers, your two answers are on a straight line and it makes what looks like a propeller. If I went back up to here, my two solutions were here was one solution and here. This does not make a straight line. If it doesn't make a straight line, I have to give the general solution for this guy and for this guy. If it makes a straight line, I could do this alternate method. So we're going to look at this one now, cos of x. So where's cos of x equal to 0? So let's write our solutions. Cos is our x values. So they want where is x 0. So this cos, that is going to be a solution. And this is going to be a solution, right? Cos is going to be 0 up here at pi over 2 and down here at 3 pi over 2. Okay, so I've got two answers, pi over 2 and 3 pi over 2. Those are my two answers. If I say, do these two answers make a straight line? So I'm just going to erase this. My two answers, you guys, were, this was an answer, pi over 2. And this was an answer at 3 pi over 2. That and this. Is this a straight line? And the answer is yes, this is a straight line. So what are all of the possible solutions? If I go to pi over 2, what would you have to add to it to get to 3 pi over 2? I hope you guys sort of see that, like, this is a straight line. To pi over 2, to get to 3 pi over 2, I would simply have to add a pi radian. And once I'm here, to get back to another solution, I keep adding pi radians. So how you would write the general solution for this one, for B, is I would take the smaller of these two, which is pi over 2, because that's the principal angle. So I would take pi over 2, and I would just keep adding multiples of pi. And that would be my general solution. That would give you every single solution in the domain x belongs to the set of real numbers. Because if you take pi over 2 and you add pi, you get to here. Add another pi, you get to here. Add another pi, you keep landing on the same spots. And again, it's a straight line, so it makes a propeller. So you just, these two, I recommend putting on your study sheets, and then you really have to just sort of think about these two. If ever you get a straight line on a test and it can make a propeller, that's where you have to think the general solution is going to be different. Okay. So this, I'm just going to star and write study sheet. And once you do like a couple of these in the homework, it starts making sense to students. Let's do this last example. Okay, so what's happening here is we have something called a restricted domain. All of the domains that we've been doing up to this point we've been finding solutions less than or equal to 2 pi, greater than or equal to 0. That's the domain that we've been working with. Essentially, what the domain we've been working with means is we've been finding solutions within 1 revolution around our unit circle. That's where we've been finding solutions. Class example 4, we've got different domains. So we've got to change or restrict our domains. So how we do this is as follows. You start with the exact same way that we've been doing. So I need everybody to isolate sine of x here. So you need to isolate sine of x, and then I'll pick somebody to give me, once you isolate sine of x, what is that going to be? So sine of x is equal to, Justin, could you tell me what you got the sine of x to be?
I got root 2 over 2.
Yes, root 2 over 2. Let's do our cast rule. Check off the 2 quadrants. Sine is positive. Everything is positive in quadrant 1 and quadrant 2. So we should have 2 different answers. We could do this in a few different ways. We could look at our unit circle, whereas sine is our y value, root 2 over 2. So just to quickly show you that, then I'm going to show you the algebra, because on all your tests, you're going to need to be able to do the algebra. So where is in quadrant 1 sine, or where's y root 2 over 2? Right here. So one of our answers is going to be pi over 4. Right, because that's where sine is root 2 over 2. And then if I go to quadrant 2, one of our answers is going to be 3 pi over 4. Oh, sorry, they want degrees. So for this question, so sorry, my answers are going to be 45 degrees and 135. What I want to show you though is let's actually do the work for this, and let's do this algebraically. So algebraically, the inverse sine of root 2 over 2, we have to be in degree mode on our calculator. So switch to degree. And let's do the inverse sine of the square root of 2. Make sure you scroll out or you'll get the wrong answer. Divided by 2. That gives us a 45-degree reference angle. So normally we would say, okay, we've got one solution here, 45 degrees. So normally we'd be like, okay, x is equal to 45 degrees. Our other solution is in quadrant 2. So remember, draw a terminal arm in quadrant 2. Put a reference angle of 45 degrees. They want the angle in standard position, which is from here to here. How you would get that is 180 degrees minus 45, and 180 degrees minus 45 will give you 135 degrees. So normally that would be our answer if our domain was from 0 to 360. But if you look, they're saying they want answers less than 720 and greater than 360. So even though these two are our answers, they don't want those answers because that's not within the domain. So what we have to do is we have to find coterminal angles to these two. So 45 degrees, if I said, well, what's coterminal with 45 degrees? Here's 45 degrees. What did we do to find coterminal angles? We just added 360 to it. If you take 45 degrees and you add 360, you're going to get 405 degrees. If I look up, is 405 degrees within this domain? Is 405 less than 720, greater than 360? Yes. So 405 degrees is an answer. I'm going to take this answer now, right? And I'm going to add, okay, so this terminal arm, what's coterminal with this guy? So this was 135 degrees. How do you find what's coterminal with 135? I could either add 360 or subtract 360. I'm going to add 360 to this one. If you type on your calculator 135 degrees plus 360, we get 495 degrees. Those are my two answers. Okay, these two answers exist in this domain. That's how you would do that. And again, could you double check that your answer is correct? Well, how you would double check is on my calculator, I would simply type in the sine of 405 degrees. And I'm going to check if once I type in the sine of 405, is that going to be root 2 over 2? So first I want to see what root 2 over 2 is equal to. And then I'm going to type in, I'm in degree mode, the sine of 405 degrees. Exact same answer. Now I'm going to type in my other one, sine of 495. Exact same answer. Okay, so that's what you would do for that question there, because they gave us a different restricted domain, and those two answers exist within this restricted domain. Let's do this last question. Okay, I need everybody to solve cotan of x for me. So I need you to solve the cotan of x. And let me know what that's equal to. And I'm going to pick Maria. Maria, what do you get the cotan of x is?
I'm not done.
Oh, sure. Okay. I'll just, when you're done, Maria, you could unpause and let me know.
Yeah, okay. So I got negative root 3 over 3.
Say that one. Oh, Marie, did you rationalize?
Yeah, I did.
You know what? Don't even worry about rationalizing right now. What would it have been if you wouldn't have rationalized?
Negative 1 over root 3.
Perfect. Yeah. And the only reason why I'm saying that, Maria, is because the reason why we don't need to rationalize this is because we're going to be finding out the reference angle anyways. So we're going to be punching it into our calculator. Okay. So yeah, you'll get the exact same answer though with your rationalized answer. Like you could use that if you want to. Okay, so this is what the cotan of x is. I can't type that into my calculator. So what I'm going to do is I'm going to rewrite this and I'm going to write down, well, what's the tan of x? Cyril, could you tell me if this is the cotan of x, what would the tan of x be? Because those are the reciprocal trig ratios. So what would I do to this answer here?
Flip it over, so it'd be negative root 3.
Perfect. Yeah, you could write negative root 3, you guys, over 1, but I would do exactly what she did. We don't need to write the over 1, so it would be negative root 3. Okay, so from here, let's do our Cartesian plane. Let's write cast. And let me know what 2 quadrants you want me to check off. Rian, could you let me know what 2 quadrants my answer is going to be in? Where tan is negative.
2 and 4.
2 and 4, he said. Yes. So you should have a check mark in quadrant 2, check mark in quadrant 4. Okay, from there, let's find the reference angle. And we could calculate the reference angle as exact pi radians in this example. So to do the reference angle, you're going to write down the inverse tan of the absolute value of negative root 3, which is just positive root 3. So I want everybody to type that into your calculators and then get the exact pi radians. So divide your answer by pi and then math 1 fraction that. Kyle, when you have that done, make sure everybody's changed their answer into radians because this needs to be in radians. Kyle, when you have the reference angle, could you let me know what you get?
Sorry.
Yeah, no worries.
Sorry, I'm having trouble. Where are you supposed to be?
Yeah, so basically, okay, so you type in second function tan of the square root of 3. This, Kyle, is the reference angle. But what I need you to do to that guy is I need you to convert it to pi radians. So get the exact, like what is this guy in pi radians? So divide that answer by pi and then math 1 fraction it.
Okay, yeah, I got 1 over 3.
1 over 3. So then what you're going to do is you're just going to tack on a pi. So he got 1 over 3, which is correct. And it's basically 1 pi over 3, and I'm just going to write down pi over 3. So the reference angle is pi over 3. Okay, so normally what we would do is we would do this. Normally we would say we have one solution up here, right? So normally I would say I've got one solution in this quadrant, and I would put the reference angle of pi over 3 here. And I would be figuring out like what that angle in standard position is. So I'd pi minus pi over 3. And then I've got one solution down here. So this one I'd be doing, if I was doing this normally, I'd be doing, so this is pi. So this one would be pi minus pi over 3. This one would be 2 pi minus pi over 3 to get that answer. But if we go to this, they tell me they want my answer from less than 0 to negative pi. So what that means is this. We know that 0 is here and negative pi is over here. They want my solution only in here. So this would be x is less than 0 and negative pi. They only want a solution there. So if I look at where my 2 solutions were, my 2 solutions were here and here. This they don't want. They only want this solution here. And then the second thing that I have to do is, because again, this would be 0. And this is now negative pi, right? So they want the solution from 0 to negative pi. So they want this answer right here. And that answer would be negative pi over 3, right? Because we're going from 0 to negative pi, and they want us to go pi over 3 radians in this direction. So the answer is just negative pi over 3. X is equal to negative pi over 3. Just to quickly show you, let's say they said this was the restricted domain. X is less than or equal to 0, greater than or equal to negative 180 degrees. Might help you if you're thinking in degrees. Pi over 3, that reference angle of pi over 3 would be, I believe that's 60 degrees. Yes. Okay, so pi over 3 is 60 degrees. This is 0. This is negative 180. If I put that reference angle of 60 degrees in here, right? So I put the reference angle 60 degrees in. We're going in the negative direction. So if they said, well, what would this terminal arm be if we're going in the negative direction? That terminal arm would be negative 60 degrees. Should ignore that. Okay, so that's how we get that answer with a restricted domain. That concludes the lesson. So here's your homework. I'm just going to stop recording the lesson.